when you're finding exponential models from given data points, it can help to pick your first starting time, or the time of your first data point as your starting time. Because when you do that, that's going to make your first value your starting value. Let's look at a problem and you'll see how this works. It says the number of severe near collisions on airway runways has decayed approximately exponentially. What that tells us, without even looking at the numbers yet, we know we're looking for a formula in that y equals a times b to the x form. From 67 in the year 2000 to 16 in the year 2010, predict the number of severe near collisions in 2025. So here we're going to take our first year and let that be our starting year. We're going to say x is equal to 0 in the year 2000. This means that our first point would be 0, 67. Then 2010 is 10 years later. Our second point would be 10, 16. Now, since that first point has an x value of 0, we already know that a is 67. And we have y equals 67 times b to the x. Now we'll use our second point to figure out what b is. We'll plug in 10 for x and 16 for y. 16 equals 67 times b raised to the 10th. We divide both sides by 67, and we have 16 over 67 equals b to the 10th. And we take the 10th root of both sides, again focusing on just the positive answer. Definitely need my calculator for this one. So let's see. 16 divided by 67, and I take the 10th root of that. I get, rounding it off to about 4 decimal places, I get that b is approximately 0.8666, like so. So our formula that we're going to use is y equals 67 times 0.8666 raised to the x. Now we still need to answer our last question, which says to predict the number of severe near collisions in the year 2025. Since our starting year was the year 2000, if we take 2025 minus our starting year, we get that we need to plug in 25 for x. So we put in 25 for x in our formula. 67 times 0.8666 raised to the 25th. So let's calculate that. 67 times 0.8666 raised to the 25th. Well, let's see. Here, I get a decimal number. You can't have a decimal number of collisions. Just like you can't have a decimal when you're counting a population, you can't have a decimal when you're counting how many times something happens. So we'll round this off to the nearest whole number, which is 2, and say that our answer is approximately 2 severe near collisions in the year 2025. If you would like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. So here we have another problem where we've got something that says it decays approximately exponentially. So we know we're looking for y equals a times b to the x. and it says we have 670 prisoners in 2003. So we're going to let 2003 be our starting year, where x is 0. So that tells us our first point is going to be 0, 670. Then for 2016, our x value is going to be 2016 minus that starting year of 2003, which is 13. So our point here will be 13, 91. Like that. The reason why we picked 2003 to be our starting year is that now we already know what we need for A. A in our equation will be 670. So we can say y equals 670 times b raised to the x. And then we'll use our second point, plugging in 13 for x and 91 for y to figure out what b is. 91 equals 670 times b raised to the 13th. Now we divide both sides by 670. I like leaving it as a fraction for right now. 91 over 670 equals b to the 13th. And then to get b by itself, we take the 13th root of both sides. So if I use my calculator to calculate the 13th root of 91 over 670, I get about 0.85764. Knowing what A is, I can write out my formula now. Y equals 670 times 0.85764 raised to the x. So now, since it's asking us to find what the number of prisoners would be in the year 2024, since our starting year was 2003, we take 2024 minus 2003, and we get that we're going to plug in 21 for x. We're 21 years after our starting year. So we have y equals 670 times 0.85764 raised to the 21. So let's try this. 670 times 0.85764 raised to the 21. Here, again, we need to round it off to the nearest whole number. You can't have a decimal number of people. So we would round this off to 27 prisoners in the year 2024.